Okay, so let's look at number 28 here. We're trying to figure out if a geometric series converges or diverges. So in the first one, we've got, let's see, 6 plus 3 plus 3 halves plus 3 fourths. You might notice that they're always decreasing by a half. Or you're always multiplying each term by a half to get the next term. So this is the same thing as the first term being just 6, the second term being 6 times a half, third term being 6 times a half squared, right? You can keep going with that. The nth term would be 6 times a half to the n minus 1, and you can keep going. Um, Now, depending on if we've talked about this in class or not, you can actually determine right away that because this is a geometric sequence or series and r is a half, it turns out any geometric series that's infinite, where r is between 1 and -1, um, that converges. So since -1 is less than r is less than 1, the series converges. Now let's say you didn't know that. The geometric only works for geometric. Let's say you didn't know that. Well, then in that case, you have to examine the partial sums. So the first partial sum is just a1, 6. The second partial sum is 6 plus 3, which is 9. The third partial sum is 6 plus 3 plus 3 halves, which is 10.5. The fourth partial sum, if you keep going, is 11.25. The fifth one, 11.625. If you keep going, like the eighth one ends up being 11.953125. And so it starts to look like maybe as n goes to infinity, the full-on sum that you get is about 12. And so we can prove it, right? If we just say, okay, let the sum be 6 plus 3 plus 3 halves plus 3 fourths plus dot dot dot, right? Well, if I multiply by a half, then I get 3 plus 3 halves plus 3 fourths plus dot dot dot. And then when I subtract out one from the other, I get s minus a half s, which is just 1 half s. And then I get 6, and all of these guys cancel all the way out to infinity, and now I'm left with s equals 12. So I've proven that the sum is in fact 12. So the series, the geometric series, converges to 12. In B, let's see, what's B? 1/64th, 1/32nd, 1/16th, 1/8. Okay, so in B, it's 1 over 64 plus 1 over 32 plus 1 over 16 plus 1 over 8 plus dot dot dot. Now if you look at this, A1, 1/64th, A2 is double that. Actually, let me write 1/64 times 2. A3 is 1 over 64 times 2 squared. And then it keeps going. And the nth term would be 1 over 64 times 2 to the n minus 1. You can kind of tell pretty quickly that this number, as n gets really big, that number is going to be huge. So successive terms keep doubling. And the limit as n goes to infinity of the nth term is also infinity. So if I keep adding up sums, that goes to infinity too, right? As n goes to infinity. So, you know, basically I'm adding bigger and bigger and bigger and bigger numbers to it. And at some point I'm adding massive numbers, so there's no way that this sum converges. The whole series diverges. Okay. And then in 28C, let's look at 28C. So 28C says, let's look at this. It's an infinite series starting at j equals 1 of 3 times 1/4 to the j. Okay, now again, this is geometric. If you think about it, the first term is going to be 3 times a fourth. The second term will be 3 times a fourth squared. all the way up to 3 times 1/4. In this case, the nth term is just to the n here, and then it keeps going. Okay. So we know it converges because our r is 1/4, and 1/4 is definitely between 1 and -1. And since it's a geometric infinite series with r between 1 and -1, it converges. And in fact, if we use our shortcut, we'll solve this one using the shortcut. So the shortcut says that it converges to this value. So the sum ends up being the first term, 1 minus r to the n. Well, actually, r is infinity in this case. I want to make sure I'm doing this right. No, sorry. Did we develop this one? Maybe we didn't actually develop this one. So let's actually work this out. It converges to, so let's write this out. S is 3 times a fourth plus 3 times a fourth squared plus dot 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 plus 3 times a fourth to the n plus dot dot dot. Actually, I don't even need this one. Let's just leave that out. We'll just do dot dot dot. So then if I do 1/4 s, the first term I'm going to get isn't 3 times a fourth, it's 3 times a fourth squared. And then the next term I get will be 3 times a fourth cubed, and all the other terms match up. So when I subtract, I've got s minus a fourth s, which is 3/4 s. And then I got 3 times a fourth minus 0, which is 3/4, plus, and then these cancel, and every term after it will cancel. So now I got 3/4 s equals 3/4, so s has to be 1. So converges, the series converges to 1.